Today we're going to be talking about Chapter 6 from the Building Java Programs book, which is about file processing. So first we're going to be talking about reading files and then writing files. And in reading files we've got two different ways we're going to read files, token-based and line-based. So let's take a look at reading files. So when you read files you're going to be using a new Java class called file. And the format is simply new file and you give it the file name. Let's take a look at an example of this. So in this main here, we're going to create a new file object using samplefile.txt. And then we're going to print to the console whether that file exists, whether it can be read, what the length is, what the absolute path is. So those are four of the functions you can use on the file method. And here's a bunch more. Probably the one that's probably most important is going to be exists, because later if you want to be able to know that the file name that's been given to you is valid, you're going to have to check whether it exists. But file is only the first part of what we need. The file then has to be actually read, and to read it we're going to use our old friend scanner. Just like we've used the scanner for system.in, now we're going to scan over a file here. And if you've been using Practice-It, then you've seen many examples where the procedure takes a scanner, and that scanner might have been created on just a string, or in this case it's going to be a file. Now there's one problem with using the file object, and that is it's called a checked exception. The file object itself declares that the code calling it either has to handle the exception or it has to acknowledge to the compiler that it knows it's supposed to handle the exception. So what we have to do is we have to declare to the compiler that we realize that a file not found exception can be thrown. So in order to do that, we have to simply write at the end of the main function, we say throws file not found exception. And then that will allow the program to compile. It's not going to handle the exception. If the exception is, if it tries to open a file which doesn't exist, it's going to throw that exception and your program's going to grind to a halt, which is why I was suggesting you want to use the file objects can exist. And that'll only happen once you actually start to access the file object. So you can check whether it exists without it throwing the exception. Okay, let's go on. So here's our first example of reading from a file. So we have to declare the main with throws file not found exception, and you also have to include java.io. Then we're going to create a new file based on samplefile.txt. We pass it into the scanner, and then we check whether the input has a next. So you remember next is for strings, has next tells us whether there is a string available to read. And then if it does have a next string, then we'll go ahead and read it, increment the count, and this will allow us to print out how many words. So one common error is that if you create the scanner with just the text file name, you may have seen this in Practice-It, where you can actually create a scanner, and to test out your function, and you can, instead of using the system input, you can actually pass in a string. Practice-It does this to test out your files. So if you create a new scanner on samplefile.txt, what you're going to be reading is samplefile.txt, just that one word. So unfortunately it's difficult to see that. The compiler is still going to allow it to work. It's going to be a runtime problem. It's not going to cause it to crash. It just isn't going to work. So in this example you'll only read one word. So there's two ways of reading files. Now that we know how to read something at all, you can either read it token by token, that's really one word at a time, anything separated by a white space, or you can do it by lines. So first we're going to look at the token based. So we've already talked about has next. There's has next int, has next double, etc. You can go through and check to see whether it's available and then read it and then do whatever you need to do with it. So this process is called consuming input, and unfortunately it's a one-way process. As you consume the input cursor is a virtual pointer into the file that keeps on going forward as you keep on reading more and more. And there is no way to scan backwards. So if for some reason you actually needed to go backwards, you would have to start all over. So if you really need to go backwards, you would probably want to store your data into an array so that you can have access to it. So practice it. You've already seen that you can pass scanners as parameters. Here's another example. So here we're opening that new file on samplefile.txt, and we call process tokens with that same scanner. And notice we're calling it with the same scanner. Each time it gets this scanner, it does not reset where the scanner points. It goes farther and farther into the file. So what this is asking for is it's asking to see 2 tokens, 3 tokens, 2 tokens. And it's not going to repeat these tokens. It's going to go on to the next ones in the file. Here it's just got a loop that gets the next token and then prints it out. So let's see what this results in. So this file must have a list of tokens that says this is a sample file for thee. And the input here being passed in 3 times gets 2 tokens, 3 tokens, and then 2 tokens. So it does not reset the file text. Paths and directories. Generally, you won't have to worry about this too much because simple examples, it'll always be in the current or working directory. Just know that if you do want to load a file with an absolute path or a relative path, you can do that. I would try to avoid it if possible for now. Now, another great exception for Java is that when you specify a file name in Windows, whereas we all know it's // something, they actually use a / so that you don't have to / escape. But that's obviously backwards, a little bit confusing. So just note that if you're going to be doing this on Windows. And you're going to be giving it an absolute path name, which I don't recommend. Okay, file name by user input. So you don't always have to know what the file name is. You can actually ask the user what the file name is. So here we create a scanner on the old system.in, the console input, asking what is the file name. Then we get that here. It doesn't have to be next line, could be next. And then we create a new file based on that name we just got. And we create a new scanner. And that is now the scanner that we're going to use to read the file. So this has 2 scanner objects, one for the console, one for the file. You have to throw the declare that it throws the file not found exception. And oddly enough, you can enter the file name, the user can enter the file name into the console with a single / C:\/ whatever, because the scanner object doesn't have to deal with any exceptions. Alright, so now we're going to look at a more complex example. So here we have a list of names. Each name has a number of hours worked, and note that we don't know how many entries we have here. So there could be 3, there could be 5, there could be 1,000,000 of them. So we're going to have to do something more clever than what we've done so far, which is just, we read, and then we move on to the next name. You're actually going to have to check. So we've got a loop here that looks kind of like a sentinel loop. We're checking to see whether the input has a next item. And if it does have a next item, then we're going to go ahead and get the input. We start the sum at 0, and then we do a while loop here while there is a next double. So that first has next is going to check whether there's a name, okay, because we don't know how many names there are. Then once we know that there's a name, we're going to do a while loop over these guys. So let's take a look at that code again. So this, we create that scanner file here, we pass it in here. This outer while loop is over the names, and this inner while loop is over the hours worked. So we've got nested while loops. So sometimes that token-based processing works fine, but other times you need to actually do it based on a line at a time. So one example why you would need to do it line at a time is if you don't want to lose the spacing here within the lines. So let's go back and take a look at the sample here. So here we didn't care about this white space here, but what if we did care about the white space? we wanted to know if there's one space or two spaces or three spaces, we would have to read a whole line at a time. And another reason why I might have to read the lines is because we care about blank lines. Here we don't care about blank lines, but what if we cared about blank lines? Then we would need to know that there was some missing name between Aaron and Simone. And a third thing is if you the nested while loops we did, so we did one while loop for the names, the second while loop was for the numbers. But what if that while loop for the numbers didn't work? What if there was another number after this that would actually mean that we were moving on to the next line? Let's take a look at an example of that. So here we have a ID for the employee. So now after I've read the ID and the name, and then I start going down here, when I look for the next double, it's actually going to find this over here. And then it's going to be confused because then it's off. So that's not going to work. So instead what we're going to do, so we open up the file. While there is a next line, we get the next line and we process the line. Process line, so it opens up the scanner on that line. It gets the integer for the ID. It gets the name string. It sets the double value sum, and then we do the while loop here. And then when we get to the end of this line, there's nothing else to read. We don't have to worry about it wrapping around to the next ID. Okay, so now we're switching to the topic of writing files. So we did reading files. Now we're going to talk about writing files. So we've spent a lot of time learning how to use print and println commands, and you all know that we do that using system.out.println. Well, system.out is a variable of type print stream, and there are other types of print streams too. You can actually create a print stream based on a file object. So we've got the same new file for a file name, but then we take that and we pass it into a new print stream. And then print stream is now just like system.out. So if you could do system.out.println, here you could do an output.println. And there actually is a way to replace the system out with your own print stream, but we won't get into that right now. So the file is always going to be overwritten if it can be overwritten. And the file that starts out is empty. And then you're going to use print and println commands. And by the time you close your program, the file will be written. So let's take a look at a simple example here. So here we got our main that again throws the file not found exception because we're doing a new file. Now it's also interesting to note that this new file is the same way that we opened up to read a file. So unlike other languages where you might have to specify whether you're reading or you're writing, this time you don't. You just say new file, whether it's reading or writing, and then PrintStream figures out what to do about it. So PrintStream is going to decide to write to that file. You could take this new file object here and you could read it too if that file did exist. So we've got PrintStream output, and now we can do output.println, and we can println anything we want. And eventually, if you hit refresh, you will see that file pop up here in your IDE. So it's important to make sure that you can actually read or write files. And so I mentioned earlier that there is a canRead object method on the file objects. So here's an example here. So we are going to try to ask a user what the file name is and then fix it if it's not right. So we create a scanner on system in. So this is going to ask the user, and really it should have printed out saying, oh, actually we're going to do that later. Okay, so we create the scanner and then we pass it in this function. This function here then actually prints out input the file name. Then we do a new file on, this is a combination here. So first it gets the string, and then it creates a new file on the string, and while it can't be read, it's going to get it again, prompting the user to try again. And then we can operate on it. So that's how you can make sure that the file exists and not throw the file not found exception. But you notice that even this routine here. Any routine that actually deals with the file object and starts working on the file object has to throw the file not found exception. It's not just main. Okay, so let's talk about what we've gone over. So we've talked about the file object, and it's important to remember that you must do a new file of the file name. If you just use the file name, the scanner is just gonna scan that one string. So we talked about the scanner object. We talked about a checked exception. That's where you have to declare that it throws file not found exception. We talked about the has next look ahead. So there's has next int, next double, or just has next for another string. We talked a little bit about relative paths and absolute paths, and how on Windows you're going to provide a slash instead of a backslash. And then we talked about the two ways that you can read the files, either with token-based processing, so you're ignoring white space, or with line-based processing, and then you will get the whole line, although you can still end up ignoring white space through using a scanner on that line. So you can have nested scanners. And then for writing, we talked about how you can use the same file object to open up a file for writing, but then you pass it into a new print stream object. And then you can now use print and println, and so then you can create an output. Now, as a footnote, there's some notes here on how to import files to use in your program so that you can read. So this is all correct. You can absolutely do this, but you can also just drag and drop in File Explorer and put it with all the rest of your files. But this shows you a method where you can make sure that if you don't know exactly where to drag and drop it, you can import files into your project. Okay, so that's all you need to know about file processing.